So today we're going to start talking about blood vessels and how blood circulates through the body. We're going to start off by talking about the various types of blood vessels in the body. So you remember, we talked about this when we talked about the heart, that arteries carry blood away from the heart. They branch as they travel away from the heart into smaller things, and the arterioles are the smallest of the arteries. They're going to carry blood to capillaries, which are the smallest blood vessels in the body. Each capillary is one red blood cell wide, and the walls of the capillaries are one cell thick. It's one layer of simple squamous epithelium. And that makes it so that oxygen, carbon dioxide, water, and nutrients can all diffuse very, very quickly into and out of the capillaries, so that oxygen and nutrients can get to cells very easily, and carbon dioxide and other wastes can be carried away from cells very quickly and easily. And then veins return the blood to the heart, and the smallest of the veins are the venules. So venules will carry blood from a capillary bed back to a larger vein, and then larger veins fuse together and finally carry blood back to the heart. All right, so let's start looking at the differences structurally between arteries and veins. So arteries and veins both have three tunics. Remember, a tunic is a layer with a similar function that may be made up of different kinds of tissues. So the tunica intima is the most internal of the layers. It faces the lumen of the artery or a vein. It is an endothelium, meaning that it's an epithelial layer that faces the inside. And it's a layer of simple squamous epithelial tissue. There's also a layer, a subendothelial layer of areolar connective tissue, just to give this tunica intima a little bit of shape. And then in the larger muscular arteries, and I'll explain in a moment what I mean by that, there is this layer called the internal elastic lamina, and that's this layer shown here. Lamina just means layer. Think of if you laminate something, you put layers of plastic on the top and the bottom. So a lamina is just a layer. So we're going to have an internal elastic lamina, and guess what? Yes, we're going to have an external elastic lamina as well. The internal elastic lamina is part of the tunica intima. Notice we don't have that elastic lamina in the veins. Now the next layer is called the tunica media, and this is layers of smooth muscle. And remember that smooth muscle cells, they have this really distinctive tapered shape. They have one nucleus per cell, and they are under autonomic control. So arteries and veins are able to expand and contract in response to blood flow flowing through them. And again, in the muscular arteries, the external elastic lamina is going to be part of this tunica media. Now, the tunica media in arteries is the thickest layer. And it is going to enable arteries, especially arterioles, to vasoconstrict, which is where the lumen gets narrower, or vasodilate, which is where the lumen gets wider. This process of vasoconstriction and vasodilation is most important in the arterioles. And we'll talk later about the function that arterioles have in maintaining blood pressure throughout the body. Now the outer layer is called the tunica externa. It's areolar connective tissue, elastic and collagen fibers, and its job is to maintain the shape of the artery or vein and to anchor the artery and vein to the other structures so that it stays in place. Notice that in veins, especially in larger veins, we're going to have this layer called the Vasa Vasorum, which is a blood supply for larger blood vessels. Now, this one also, especially the larger arteries, also have a Vasa Vasorum, especially to provide blood supply to the smooth muscle in the tunica media. In the veins, the Vasa Vasorum is going to be the thickest layer. Okay, and you can see all those little blood vessels in there. So this is carrying blood, and then it also has its own blood supply. Now, the difference between arteries and veins, arteries, the lumen is narrower. The lumen of veins is larger. Arteries have a lot more elastic and collagen fiber throughout the tunics, and arteries are able to stay open because of especially the collagen. They're able to stay open even if blood isn't flowing through them. They're also, because of these big layers of elastic and smooth muscle, they're able to withstand changes in blood pressure. If you think of the heart beating and sending pulses of blood through the arteries, these arteries constantly need to be able to expand to accommodate that pulse of blood and then come back to their original shape to get ready for the next pulse of blood. As they do that, as they expand and then slowly return to their original shape, they actually smooth out the pulses and decrease the pressure of the blood as it moves to the next area. Valves have a wide lumen, veins, have a wide lumen, and they have valves. That's where that was coming from. The valves are just extensions of this endothelium in the tunica media. And the cool thing about that is they prevent blood from going the wrong direction in the veins. So by the time the blood gets to the venous circulatory system, it's already gone across these tiny little capillary beds. And it's lost almost all of the pressure from the arterial blood supply. So we have other ways to keep the blood moving through the valves, and one of the really helpful parts is that these moving through the veins. I don't know why I can't say that. One of the other things is that these valves in the veins prevent the blood from just flowing back down, especially, for example, in the legs, where if these valves weren't there, the blood would just flow down and then pool at your feet, and it would be very hard to get the blood back up to your heart. All right, now capillaries connect arteries and veins. They have only the tunica intima and a basement membrane, and that's all. The walls, because the walls are so thin, gas exchange is really, really easy, and oxygen and carbon dioxide are going to diffuse very, very easily across the walls of the capillaries. Okay, I'm going to stop there, and on the next section, I'm going to talk about capillaries specifically, including the different types of capillaries. And I'm not going to stop there. Not yet. Hang on. There's more. Okay, on a microscope slide, we can see very clearly the difference between an artery with this really thick muscular wall and a vein with a much larger lumen and a much narrower muscular wall. If we zoom in on this, there we go, we can see the three tunics very clearly. You can see this tunica intima here. These are all little red blood cells that were trapped in this when it was sectioned. We can see this smooth muscle here, and then out here, the tunica externa with that Vasa Vasorum. If we look at the vein, we might need to zoom in a little more. Nope, that's as far as we can go. We can see, it's a little harder to see the tunica intima, but there it is right there. You can see that one little layer. Then we have a thin layer of smooth muscle and then a thicker layer of the Vasa Vasorum in the tunica externa. Okay, notice around it we have fat cells, and that's normal to provide padding and things to keep the blood vessels in place. And again, blood cells, red blood cells trapped within those. Okay, there are three categories of arteries. The largest are called elastic arteries. They have the most elastic fibers in them. These are also called conducting arteries because they conduct blood away from the heart towards smaller arteries. So the aorta is a conducting artery, the pulmonary trunk and the pulmonary arteries, the brachiocephalic arteries, the common carotid arteries. I know you don't know what these are yet, but you will in a moment. And when you come back, these will all make sense. So the big arteries in the body, the ones that branch directly off of the aorta, these are going to be elastic arteries. They have a very thick tunica media with lots and lots of elastic tissue in the wall. There's a video on my YouTube page of a heart dissection, and you can see that both the aorta and the pulmonary trunk, the walls look white, even though there's a lot of smooth muscle there. There's so much elastic tissue that the walls of those arteries actually look white. So the elastic arteries, we have this really thick tunica media, and you can see that it doesn't so much look like smooth muscle as it looks like elastic fibers. It looks like elastic tissue. So it is smooth muscle with lots of elastic fibers in it. That's what we're looking at there. And that again enables them to stretch during ventricular contraction. So as they get a pulse of blood from the heart, they're able to stretch and then return back to their original shape. Now the next group of next group of arteries are called muscular arteries. These are also called distributing arteries because they're going to distribute the blood from the conducting arteries to specific organs and tissues. So most of the named arteries that we're going to learn today are going to be muscular arteries, the ones that go, for example, to the arm, brachial, tibial, coronary, inferior mesentery. These are all muscular arteries. And again, they do have the external and internal elastic lamina surrounding that layer of smooth muscle. But as you can see, not as much elastic tissue within that smooth muscle. Okay, and for those of you who are wondering, do you have to recognize these on a microscope slide? You absolutely do. Right? Yes, these pictures will be on the desk. Maybe not these exact tissue pictures, but maybe. All right, so here you can see that tunica intima, and it's folded so that as the pulse of blood comes through, it can expand. And then you can see here, this dark layer right there, that's the internal elastic lamina, the tunica media, and then another dark layer around the outside, that's the external elastic lamina, and then the tunica externa out here, and then connective tissue holding this artery in place. And then the smallest are the arterioles. We're going to have arterioles that as they branch get smaller and smaller and smaller. So there are actually many different sizes of arterioles. The largest arterioles are going to have all three tunics. As they get smaller, they lose the tunica externa. Some of them have just a kind of little wraps of like single strands of smooth muscle as the tunica media rather than a full layer. They all have a tunica intima. So this is what that looks like. And this is a higher magnification. So we can see the individual cells in the tunica intima. And you could actually count the layers, like 1, 2, 3, 4, maybe 5 layers in the tunica media. These are the ones, these arterioles are going to do most of the vasodilation and vasoconstriction to help control blood pressure. As these vasoconstrict, they decrease the overall surface area for blood in the body and raise blood pressure. They literally raise the pressure of the blood on the walls of the arteries. As they dilate, they decrease that pressure and bring down the blood pressure. Okay, now I'm going to pause and come back to the capillaries for another section.